Welcome back. Let's move on with our subject. Let's do some dot product application. In this case, there are mainly uh, two ways that we can apply the dot product to solve engineering problems. Uh, One of them is to compute or to find lengths and angles. Okay, this is the two formulas we have to calculate that product. The first one is the addition of the product between the elements of the components A sub I times B sub I. And the second formula is the second way to calculate the dot product is the length or the modulus of the first vector times the modulus or the length of the second vector, and that times the cosine of the angle between these two vectors. So we have here a three-dimensional plane, and we have 3 points. Point M. The point M is located at 0 x axis, y axis 0 in the y axis, and 4 in the z axis. So this is point M. The point P is located at 1 unit positive in the x-axis, 1 unit positive in the x-axis, 0 in the y-axis. So this is right on the origin, and 0 in the z-axis. So there's no upward position for this one. So it stays there only in the 1, 0, 0. The point Q is located at 0 on the z-axis, 1 unit in the y-axis positive here, and 0 units in the z-axis. So it's no height. And this is point M, point P, and point Q. We can connect these points together. Let's connect them so we can visualize them better. You can connect point M with point P. Let's connect point M with point Q, and finally let's let's connect point P and point Q. Okay, that's it. So these 3 points forms a plane. Um, this plane it extends in all ways into the directions of the three-dimensional space, but we are connecting these points just to visualize and let us know that this plane is formed by these three vectors. Okay, let's say that someone is asking us to calculate the angle, in this case the angle theta, between these two lines over here. So this will be our angle theta, and we want to know what this angle is between vector PM and vector PQ. So we need to know what this angle is. Okay, uh, you have two formulas here. If this is your problem or your question, how can we calculate the angle between vector PM and PQ? Well, if you take a look to this second formula, you will find that here we have as a component of this expression, we have the cosine of theta, that's the angle. So if we expand this formula, we can come up with this. We have our first vector, which is vector PQ. This is the vector PQ. And we know that the dot product of two vectors, our second vector will be PM. We know from this first formula and from this second formula that the dot product between two vectors equals, for this case, the length or the modulus for vector PQ times the length or the modulus for the vector PM times the cosine of the angle between them. Okay, if we solve for the cosine of theta, doing a little bit of algebra, let's move this expression to the left. So this will be the cosine theta times the modulus or length of PQ times the modulus or length of PM equals the dot product of PQ, PM. So if we isolate the cosine, we can move this as a denominator for this expression, and we can come up with this, that the cosine of theta equals the dot product of vectors PQ, PM divided by the product of their lengths, which is the modulus of PQ times the modulus of PM. Okay, so doing a little bit of algebra, we can come up with this, and we know that once we get the cosine of an angle, the cosine equals this expression. If we calculate the inverse cosine of this, we will know what the angle between PM and PQ is. So let's do the calculations. So the first thing that we need to know is the components of the vectors. So let's calculate the components of the vectors. Our first vector is PQ. The components for vectors PQ, if you remember from the formula, the components of the vector is, in this case, from PQ is going to be 0 minus 1, that is minus 1. Then 1 minus 0, that's equals to 0 to 1. And 0 minus 0, that's equals to 0. So that's the components for vector PQ. Let's do the components for vector PM. Components for vector PM are 0 minus 1, that is also minus 1. Then 0 minus 0 is equals to 0. And 4 minus 0, that equals 4. So I'm using the formula that I shared to you in the first module. It was the basic operations for vectors. You want to recall this, please take a look at the first videos, and then you will find a couple of exercises on how to calculate the components of a vector. So here we have the components for vector PQ and components for vector PM. So we have all these two parts in place. Now the next step that we need to do is to calculate the length for vector PQ and the length for vector PM. So as we know, the length for the vector is just the sum, the root square for the sum of the square values of their components. So the length for vector PQ, and it will be equal to the root square of minus 1 square plus 1 square plus 0 square, and this is 1 to the square is 1, 1 to the square is also 1, so the modulus or the length for this is square root of 2. So this is the length of vector PQ. Okay, uh, let's do the length for vector PM. And the length for vector PM is also root square of minus 1 square plus 0 square plus 4 square, and that's equal to, and this is equals to 1, this is 0, and this is 4. The square is 16, so the length for the vector PM will be root square of 17. Okay, now we have the lengths for these vectors, we have the components for these vectors. Now the next step is to substitute these values into this expression, so we can get the cosine or the quotient from the sides this represent these two vectors in the plane. Okay, solving for that and doing the substitution, then this will be equal to the components for vector PQ, uh, minus 1, comma 1, comma 0, dot product, the components for vector PM, minus 1, comma 0, comma 4, divided by the lengths, the product of the lengths of the vector, which are square roots of 2 times square root of 17. We did the dot product here. Remember, the formula for dot product is the sum of the multiplication of each one of the components uh, with reference with one of the axes. So this x, y, z, x, y, z. So minus 1 times minus 1, that is equal to 1. 1 times 0 is 0, and 4 times 0 times 4 is 0, so this is going to be equal to 1. And applying the rules for the radicals, we can say that this is equal to 34. So the cosine of theta for the angle equals 1 divided by the root square of 44. So this is the cosine of theta of the angle that we are working with here in this triangle there. Okay, so I'm doing this step by step because you're going to do a lot of exercises in the future in the same way. So please take note. You have these two expressions right there, and this is one of the application of the dot product in vectorial calculations. Um, our recommendations from myself to you is from now and forever set your calculators to radians. Okay, so the degrees are not allowed in this subject. Okay, if your physics professor or someone asks you to use degrees, you can switch your calculator to degrees, but for this subject, we are going to work with radians. So get used to calculate based your angles based on radians. Okay, so the cosine of theta equals 1 divided by the root square of 34. So if we want to solve this, then we can know that the angle theta is going to be equal to the inverse cosine of 1 divided by root square of 34. Okay, if you do your calculations, you can get into your calculator this value first and then do the inverse cosine. This is the same that the ACOS in your calculators, and this is equal to 1.39 radians. Okay, 1.39 radians. So the angle between vectors PQ and PM, this is equal to 1.39 radians. If you are not familiar yet with these radians and you want to by now do a conversion from radians to degree, then you can do the next operation. So radians, we in this case, you want to convert from radians to degrees, you can multiply radians times 180 divided by pi, and you will have your angle in degrees. Okay, so if you do this in calculation on your calculator, you will come up with an approximation of 80.12 degrees or something like that. So 80 degrees equals more or less 1.39 radians. And that's it for this module. Uh, I'm expecting to be clear enough. You can take notes of this. Please, if you have questions or you are in doubt regarding this little exercise, please let me know. Leave your comments on the video or send a message or write an email, and I will be answering your questions. Bye.